going to turn into gas. Now I'm going to do something which you should never do.
Is it cold?
Right? I'll take that onto my hand because my hand is hot and the nitrogen is really cold and boils at a low temperature, minus 200 degrees nearly. And what it does, it hits my hand and it turns into gas immediately and protects my hand. So there's a little gas film on my hand so my hand doesn't get hurt. Now obviously, if I tip it in my shoes, it's going to get trapped and it's going to freeze my foot off. So you don't want to do that. But I've already spilt most of it and we can...
Wow.
That's all gone. Right?
Why does it rain?
Okay.
Behind the lines.
So the other component in the atmosphere is oxygen.
Listen.
And we can make oxygen from a chemical called hydrogen peroxide. Now, ordinary water is H2O. So it's got 2 hydrogen atoms and 1 oxygen atom. Hydrogen peroxide, well, per means lots. So it's got more oxygen than ordinary water, and its formula is H2O2. I'm going to put some in here. This is actually used as a disinfectant, and it's used as, like, to bleach your hair, turn your hair white. I haven't got very much hair, so we're not going to try doing that. So there's a little bit of hydrogen peroxide in there, and it's actually quite unstable. It doesn't want to be hydrogen peroxide, it wants to be water and oxygen. And it's used as a rocket fuel, on its own as a rocket fuel, right? So, we make hydrogen peroxide in our body because it's oxygen in the air we breathe, and some of it produces hydrogen peroxide. So our bodies produce things called enzymes, which are they're chemical compounds which speed up reactions. They're called catalysts, so they make things go faster without being consumed. Now, I could cut my finger and I could drop some blood in there, and it would cause the hydrogen peroxide to decompose. But I'm not going to do that because I don't want to cut my finger. But I've got some yeast here, and that contains the same enzyme that will destroy the hydrogen peroxide. So there you go. And those bubbles are oxygen. Now, somebody said elephant's toothpaste. Well, this is sort of the elephant's toothpaste experiment. Because if you put soap in there, all that will come out. Now, it's cold. It's not getting hot. It's just producing bubbles, and we can see how good it is by taking this candle. This may not work, so I just try and trap some of the oxygen in there. Right? Oh. You can see it's glowing brighter, even though it's gone out. So it's out there, you put it in, and it goes brighter because there's more oxygen around. Now, the test for oxygen actually is to take a match, and then light the match, blow it out, so it's glowing like charcoal, stick it in oxygen and it will relight. This doesn't always work, you need to get more oxygen in. So we've done the 2 big components of gases in the atmosphere. Carbon dioxide is a gas produced by us breathing. So we breathe in oxygen. The oxygen goes into our bodies, and the food that we eat contains things like carbohydrates, so there's carbon in there, and we breathe out carbon dioxide. So that's oxygen, nitrogen, carbon dioxide. We're going to make another gas, which John will know about, because he goes caving like I do. That's how we know one another, and he might remember the days when people used carbide lights. Possibly he's too young for that, because I'm very old.
Very long time ago.
I'm very old, but no one these days uses them. But I've got some carbide here. So
Find out. Carbide is like a rock.
A rock. This is like a rock here.
A rock.
I'm not going to use very much because this actually gets quite lively. So this is calcium carbide, and now, as a chemist, you don't smell things like that. You go like this to smell them because that way you don't breathe in too much. You shouldn't smell or taste things that you don't know what they are. People die that way.
Oh.
So that's calcium carbide, and it's quite dangerous. I keep it out of the way and pop that in there. And I'm going to get some water from our leftover supply of water from the rockets. So what you would do, my grandfather was a coal miner, and he used to use a carbide light because they didn't have electric lights. They put these rocks in, and it generates, when you add water to this, it generates a gas called acetylene. Now acetylene is a hydrocarbon. It contains hydrogen and carbon, and it burns.
That is dangerous.
So that's acetylene, and it's gone out there. There you are. Unfortunately, it tends to generate lots of bubbles, so the bubbles tend to sort of like get water up and put it out. So,
Is it dangerous?
well, it is actually, because I mean, you can set people's hair on fire with this. People, when I started caving, people used carbide lights, and I remember going caving once up in the Yorkshire Dales, and my friend was using a carbide light on his helmet, and he looked at my girlfriend, and then looked away again, and then I could smell this burning, and her hair was on fire. So we had a great caving trip, but she came out with a haircut. So there you are. So that's carbide burning. The problem with that is it contains carbon and hydrogen. It produces a lot of soot. That's elemental carbon. That black stuff is soot. But the nice thing is it gives you a nice bright light. Okay? That yellow flame there is nice and bright. You can see, you can go caving with that.
Why is
if you
it
want.
not going out?
I don't think anybody ever does it these days, but that's a carbide light, and that's how they work.
Can you smell it, Cubs? Can you
Smell
smell
that.
that?
That's because the calcium carbide not only contains calcium and carbon, it also contains calcium and sulfur. And sulfur is that rotten, smelly, eggy gas, farty gas, right? That's so it produces hydrogen sulfide. That smells of rotten eggs. It produces sulfur dioxide, which is a nasty corrosive gas. That smells like burning coal and stuff like that. So that's the other pollutants, and that's my job, is to stop that. So that's let's put this out of the way. I can demonstrate how to put it out. The way to put fire out is
What?
right. So have you done your fire warden thing?
Yeah.
We did fire safety last week.
Yes. Right.
Where to find you?
Do you know about the fire triangle?
Yeah.
Right. Tell me what the fire triangle is. You that in the. Yeah.
999.
No, that's what we do when there's a fire. What do you need to have a fire? 3 things for a fire. In the middle? Yeah.
Oxygen, fuel, and can't remember the third one.
Right. Well, they are. You've got to have something to burn. There you are. You need energy to start it burning. So you need an ignition source, something to
Need
start.
friction.
So that was my ignition source. In there's a little sparky thing, right? That lights the gas, and then the gas lights up. So that's my ignition source. You've got to put energy in, because when it was producing acetylene, it wasn't going to burn because it didn't have the ignition source. And obviously, you've got some air around it. So if I put my hand over it, there you are. That stops the air getting to the acetylene, and the fire goes out. So, if you want to stop a fire, you take away the fuel, you take away the oxygen, or you make sure that there's no ignition source around. Okay? So that's my lecture on fire safety. Do I get a badge?
You can have a fire safety badge.
I will. I am a fire warden. Yeah, I will have a fire safety badge. So, the last one is a lot of fun and can be loud.
I love fun.
Pack.
At ease.
This is stuff called caustic soda, and it's used. You know, you can buy it in the shops. It's used the original and best drain cleaner. So if anybody's got a blocked drain, I'll come round to your house later on and fix it.
do.
But it says on the back, well, danger corrosive, and then it says don't get near aluminium. So I'm going to get it near aluminium. So I'm. So that's caustic soda. Sodium hydroxide is its chemical name, NaOH. Na is the symbol for sodium after the Latin natrium, which is what the Romans called that. So I'm going to make some very concentrated solution of sodium hydroxide. Right? Much too strong, and that is getting hot, right? Because when it dissolves in water, it gets really quite hot, and then I'm going to do what it says don't do.
You're a real scientist. He is. No. You're crazy.
So we're going to get some aluminium. Now people think as aluminium as not being very reactive. That's because aluminium is covered with a very thin layer of stuff called aluminium oxide, which is very thin, so you can see the shiny metal underneath it. But if you dissolve away that, it reacts. And that's quite a lot. There you go. That's producing hydrogen. Watch this.
It's like the kettle's gonna go off.
That's hydrogen. Now, if you get it right, it'll actually go bang. But I produce so much, it's actually coming out as a flame. Now, I'm going to do, this is like really about sciencey stuff. Now, this is what I do for a living, right? That flame is actually, the hydrogen,
That's why it's difficult.
when it burns, got rid of it all. Let's try a bit more. It burns with an invisible flame. And that, what you can see, you can see that yellow, that's actually because there's some sodium hydroxide in there. It's producing that yellow flame. So when you look at the street lights, you see the yellow street lights. You familiar with those?
Yeah.
Those are sodium lights. They've got sodium in them, and the sodium's getting all excited, and it's giving off light. So that's what's happening here. The sodium's getting all excited, but the hydrogen is burning with an invisible flame, and that's why hydrogen is very dangerous. It's it burns with lots of proportions in air, so it will burn very easily. It doesn't give off very much heat, but that's quite safe. But if you're ever in a hydrogen fire, you can walk straight into it, and the first thing you know is all your hair's on fire. This is why I don't have any hair. All right, there's hydrogen fires for you. So there we go.
Oh.
There we go. Hydrogen. Thank you very much. It's been great to listen to.
Fantastic.
How many